Look around you. Your city, your economy, the simple biological fact that you are alive right now. All of it rests on a chemical accident. Not a philosophy, not a political movement, not some great leader's vision. A chemical accident. By 1890, the mathematics of human survival had hit a wall. The Earth's soil was hemorrhaging a single invisible element, and without it, nothing grows. Not wheat, not corn, not rice, not grass. Nothing. The planet's agricultural capacity was collapsing in slow motion, and the worst part was that almost nobody understood why. Fields that had fed empires for centuries were quietly turning to dust. And the only reason that collapse didn't wipe out most of the human race is one of the strangest stories in the history of civilization. Because before we found a permanent solution, the most powerful nations on Earth, the British Empire, the United States, Spain, sent their warships across the Pacific to fight over mountains of dried bird droppings on tiny, barren islands nobody had ever cared about before. That was the emergency plan. Bird excrement, shipped across oceans by the millions of tons just to keep the dirt alive long enough for someone, somewhere, to figure out a real answer. And when that answer finally came, it didn't come from the ground at all. It came from the sky. This is the story of how a single missing chemical nearly ended human civilization and how we cheated our way out of extinction. So what was this invisible chemical that was quietly killing the planet's ability to grow food? Nitrogen. That's it. A single element on the periodic table. Every living plant on Earth depends on nitrogen to survive. It's the backbone of chlorophyll, the core ingredient in amino acids, and the fundamental building block of DNA. Without nitrogen in the soil, a seed can sit in perfect conditions. Plenty of water, plenty of sunlight, rich, dark earth, and it will simply refuse to grow. The stems go brittle, the leaves yellow, the plant dies. Nitrogen is the invisible engine behind every harvest in human history, and for thousands of years, nature managed the supply chain on its own. Here's how it worked. Plants pulled nitrogen from the soil to grow. Animals ate the plants and absorbed the nitrogen into their bodies. When those animals died, or when they produced waste, the nitrogen cycled right back into the dirt. Farmers understood this loop intuitively, even if they didn't know the chemistry. They rotated their crops. They let exhausted fields rest for a season. They spread animal manure across the soil. The cycle was slow, but it was reliable. As long as human populations stayed relatively small and mostly rural, the loop held together without much trouble. Then the Industrial Revolution shattered the entire system. Within a few decades, millions of people migrated from the countryside into rapidly expanding cities. London, Paris, New York, Berlin. These massive urban machines demanded staggering amounts of grain to feed their populations. So we stripped the farmlands bare. We shipped crops into the cities by the trainload, week after week, year after year. But the nitrogen locked inside those crops never made it back to the farms. Instead, human waste was flushed into sewers, dumped into rivers, and carried out to the ocean. Gone. Permanently removed from the agricultural cycle. We had severed the nitrogen loop, and the consequences were catastrophic. Fields across Europe and the eastern United States were quietly dying. The water was there, the sunlight was there, farmers were working harder than ever, but the soil was dead. The invisible engine had stopped, and nothing anyone did could restart it. Now here's what makes this crisis so maddeningly cruel. We were surrounded by nitrogen, drowning in it. 78% of every breath you take is nitrogen. The entire atmosphere is a vast, limitless reservoir of the exact element that the soil was starving for. But it was completely useless. Atmospheric nitrogen exists as pairs of atoms welded together by one of the strongest chemical bonds in nature, a triple covalent bond that flat out refuses to break under normal conditions. Plants can't absorb it from the air. Animals can't metabolize it. You could stand in the middle of a dying wheat field, lungs full of nitrogen, and watch the crops wither around you. The resource was everywhere in functionally infinite supply, and no living organism on the planet could access a single molecule of it. It's like dying of thirst while floating in the ocean. The water is right there, but it'll kill you before it saves you. Nature had exactly two mechanisms for converting atmospheric nitrogen into the usable form that plants actually need. The first was a handful of specialized bacteria that lived on the roots of very specific plants, legumes mostly, like beans and clover. These bacteria could slowly crack nitrogen molecules apart and fix them into the soil, painfully, geologically slow. The second mechanism was lightning. A bolt striking the ground generates enough heat to momentarily split atmospheric nitrogen apart, producing trace amounts of usable compounds that rain down into the soil. But lightning is random, infrequent, and covers tiny areas. That was the ceiling, the hard, non-negotiable physical speed limit on how fast the human species could expand. We could only grow as much food as bacteria and lightning allowed. And by the mid-1800s, we had blown past that limit with reckless, unknowing abandon. The demand for grain was exploding, European harvests were shrinking year after year, and the scientists who understood what was happening were terrified, because the math was brutally clear. Without a way to force massive amounts of usable nitrogen back into the world's farmland, a global famine wasn't a worst-case scenario. It was an inevitability. So the empires of the world did what empires always do when they're desperate. They looked outward. If the soil couldn't produce nitrogen fast enough, they needed to find a massive natural stockpile somewhere, anywhere. And they found one, in the most bizarre and unlikely place imaginable. A handful of barren, sun-blasted rock islands off the western coast of Peru. For thousands of years, millions of seabirds had roosted on these desolate outcrops in the Pacific, and because it almost never rains in that particular stretch of coastline, their droppings never washed away. Layer upon layer, century after century, the guano accumulated into towering cliffs of hardened, sun-baked waste, some reaching over 150 feet high. And because of the arid conditions, this ancient guano contained ultra-concentrated, immediately usable nitrogen in quantities that seemed almost miraculous. Overnight, these forgotten rocks became the most valuable real estate on Earth. More valuable than gold mines, more valuable than oil fields, which hadn't even been discovered yet. This was food. This was survival itself. The world's greatest naval powers redirected entire fleets to secure access. Picture it for a moment. British warships, American frigates, Spanish galleons, vessels designed for imperial conquest and global domination, reduced to glorified cargo barges, hauling millions of tons of ancient bird excrement across the Atlantic and around Cape Horn. The working conditions on the Guano Islands were nightmarish. Laborers, many of them enslaved or indentured, chipped away at the cliffs with pickaxes. The fumes were so intense that workers reportedly went blind. Ships anchored offshore could smell the islands from miles away. But it worked. The guano hit the dead European soils, and crop yields exploded almost overnight. Fields that had been failing for years suddenly produced record harvests. Populations stabilized. The famine was delayed. And that was exactly the problem. It was delayed, not solved. Those guano mountains had taken millennia to build, and we were consuming them in decades. The entire Western food supply now depended on a finite, rapidly shrinking pile of bird droppings on a few rocks in the Pacific. We hadn't fixed the broken nitrogen cycle. We'd just found a temporary patch, and the patch was running out fast. What started as a scientific crisis became a geopolitical nightmare almost overnight. In 1898, Sir William Crookes, one of the most respected scientists in the British Empire, president of the British Association for the Advancement of Science, stood at a podium and delivered the kind of warning that makes governments lose sleep. He stated plainly that England and all civilized nations stood in deadly peril of not having enough to eat. He had done the arithmetic. At current rates of soil depletion and population growth, the 1930s would mark the point of no return, the moment when the world's population would permanently and irreversibly exceed the planet's capacity to feed it. The scramble that followed was frantic and at times absurd. The United States Congress passed the Guano Islands Act, one of the stranger pieces of legislation in American history. It authorized any U.S. citizen to claim any uninhabited island anywhere on the planet in the name of the U.S. government, with one condition: the island had to have guano on it. Under this single law, the U.S. claimed over 70 islands across the Pacific and Caribbean. Some of those territorial claims still exist today. But laws weren't enough. Real wars broke out. Spain attempted to seize Peru's Chincha Islands by force, triggering a naval conflict that saw warships exchanging cannon fire off the coast of barren white cliffs. These weren't wars over ideology or territory in any traditional sense. They were wars over fertilizer, wars over bird droppings, wars to delay starvation for one more decade. Shipping networks stretched to their limits, with entire logistics chains existing for the sole purpose of moving nitrogen across the world fast enough to keep harvests alive for one more season. And everyone involved knew the truth. The guano was vanishing. The cliffs were visibly shrinking. The system was on borrowed time, and there was no backup plan. Until two chemists in Germany looked at the problem from an entirely different angle. If the ground couldn't feed humanity, they wouldn't try to fix the ground. They would bypass nature entirely. They would pull what they needed straight out of the air. Fritz Haber and Karl Bosch didn't find a new island. They didn't conquer a new territory. They built a machine that changed the fundamental equation of human survival. The concept was elegant and terrifying in its ambition. Take the vast, useless nitrogen floating in the atmosphere and force it, under extreme, unnatural conditions, to bond with hydrogen, producing synthetic ammonia. Ammonia that could be converted directly into fertilizer. Food manufactured from air. On paper, the chemistry was straightforward. In practice, it was a nightmare. The reaction required temperatures exceeding 500 degrees Celsius and pressures of around 200 atmospheres, conditions so extreme that the steel reactors of the era couldn't survive them. Early prototypes ruptured, pipes burst, engineers were killed by explosions. The metallurgy simply didn't exist yet. Karl Bosch, an industrial chemist with an obsessive talent for scaling the impossible, spent years iterating on reactor designs. He tested hundreds of alloy combinations, searching for metals that could contain the violent reaction without cracking, and eventually he found them. The first successful industrial-scale Haber-Bosch reactor came online in 1913. It worked. They had bottled the sky. For the first time in the entire history of life on this planet, a living species had completely bypassed the natural nitrogen cycle. No more waiting for bacteria, no more depending on the random strike of lightning, no more shipping bird excrement across oceans on warships. You could now manufacture the fundamental chemical building block of food inside a factory, pour it into bags, load it onto trains, and spread it across any field on Earth. The Haber-Bosch process didn't just solve the nitrogen crisis, it obliterated the biological ceiling on human population. Within a single century, the world went from under 2 billion people to over 8 billion. That growth curve is almost entirely synthetic.
We stopped playing by the rules that nature had enforced for billions of years and started writing our own.
Here's the part that should genuinely unsettle you. Nearly half of the nitrogen atoms in your body right now, in your DNA, in your muscle tissue, in the hemoglobin carrying oxygen through your bloodstream this very second, didn't come from the Earth. They came from a factory, a machine running the exact same chemical process that Fritz Haber perfected over a century ago. If those factories stopped running tomorrow, half of the planet would starve within months. Not years, months. That's not alarmism or speculation, that is the math. The natural nitrogen cycle, left on its own, can only support roughly 3 to 4 billion people. We are 8 billion. The gap between what nature provides and what we need is filled entirely by synthetic chemistry, running 24 hours a day in industrial plants scattered across the globe. You aren't here because of natural selection. You are here because two chemists figured out how to crack open the atmosphere and pull survival out of nothing. You are, in the most literal biochemical sense, a synthetic product of the Haber-Bosch process, walking around on a planet that was never designed to support this many of you. The greatest crisis in human history wasn't a war, it wasn't a plague, it wasn't an asteroid. It was the quiet, invisible depletion of dirt, and we only survived because we learned how to turn thin air into bread. If the hidden logistics behind civilization's survival fascinate you, there are more stories like this one: buried systems, invisible limits, and the engineering miracles we never talk about. Subscribe, and we'll keep digging.